IEEE Radio and Wireless Week was held in Anaheim, California from the 14th through the 17th of January 2018. RWW is an annual technical conference from IEEE and is sponsored primarily by Microwave Theory and Techniques Society. It consists of 5 different co-located topical conferences. One of those conferences was the Topical Workshop on the Internet of Space, or TWIOS, with 2 sessions, and there was also a CubeSat Workshop. This conference was great. Here's an overview of the speaker lineup for the workshops. The first workshop was about digital predistortion. Digital predistortion is a technique used to increase the efficiency of power amplifiers. By reducing the distortion created by running power amplifiers in their nonlinear regions, power amplifiers can be made to be far more efficient. Radio power amplifiers tend to become more nonlinear as their output power increases towards their maximum rated output. Predistortion is a way to get more usable power from the amplifier without having to build a larger, less efficient, and more expensive amplifier. You can do this in the analog domain or the digital. This workshop was about digital predistortion techniques. We need to know about this because it will help us. I have all the papers and the workbook, so if you're working on DPD, get in touch for these resources. Another workshop was solid-state amplifiers for space. Here's the lineup, and I have the workbook, but it was at the same time as the digital predistortion, so I didn't attend in person. Same deal, I have the papers and the workbook, so get in touch if you want to work on this. The big workshop draw for me was the next day, the Microwave CubeSats and Small Satellites Workshop. Here's the summary and the lineup. Microwave and millimeter wave CubeSats are the thing. So, we're definitely on the right track. Being opportunistic and ready to deploy communications and scientific experiments in the rapidly growing CubeSat market are going to be vital for keeping in the mix going forward. Every slide that I saw for CubeSat launches has an almost exponential curve, with most of that curve taken up with commercial operations. The number of launches for educational and scientific missions is expected to be relatively flat on all these charts. With more and more universities and institutes putting together CubeSat programs, where does that leave amateur and educational efforts? Not all CubeSats are LEO, but most of them are. What it means to me is that things are about to get a lot more competitive, as the pressure on launch agencies to increase capacity and the competition for launches is expected to dramatically increase over the next 2 years, just in the university space. The introduction to the workshop was Challenges and Opportunities for the Internet of Space. The premise that microwave CubeSats and small satellites need to meet the needs of the Internet of Things, or the Internet of Space, was a constant theme for the entire conference and for this workshop especially. There are a lot of questions about IoT and 5G for that matter. Example 1. Aircraft sensors with data aggregation in the air and the results communicated via SATCOM to make in-air decisions between gates for unscheduled maintenance in order to keep aircraft continuously healthy and monitored. Another example, remote monitoring of industrial vehicles where satellites make the most sense. CubeSats with phased arrays, CubeSats that avoid data collisions, CubeSats that have enough power for desired payloads, and they're talking like 10 to 20 watts. CubeSats that have attitude control, CubeSats that are reliable with COTS or commercial off-the-shelf devices. An example given was Iridium. Iridium used COTS devices for large parts of the system. Lifetime requirements, use cases, sustainable business models, propulsion systems like Nano FEEP or Nano FEEP, business cases, capital expenses, and launch costs. All these things are challenges. So this workshop was all about the solutions for those challenges, or at least some of them. There's a lot of careful COTS, COTS, or commercial off-the-shelf, discussed at this conference. If you're not familiar with that term, it means that you construct your circuit from radiation-tolerant, commercial, off-the-shelf components that were not necessarily specifically designed for space. Then you test your design at the system level, possibly putting in redundancy and other mechanisms to recover from radiation-induced events. Careful COTS is in contrast to the much more rigorous and expensive, designed for space from the beginning, heavily integrated solution that we most often call radiation hardened. Dr. Klaus Schilling spoke about a standardized electrical interface for CubeSat bus interfaces. You can download the PDF here. The success of the CubeSats was based on standardization of geometric dimensions, allowing joint use of launcher adapters. An important next step in order to be able to exchange boards at subsystem level was a specification and standardization of the electrical interfaces, which is addressed in this contribution. The standard is pretty good. Satellites have been successfully launched using this standard, and the advantage is no wiring harness, dramatically reduced assembly time, the ability to swap out failed parts at the last minute, increased reliability, and increased interoperability. Dr. Schilling heads up the University Würzburg Experimental Satellites, or UWE, program, and there's a link below. UWE-3 was launched in November of 2013. The main mission objectives of UWE-3, or UE-3, are to demonstrate the use of a real-time miniature attitude, determination, and control system on board the satellite, using a variety of sensors, magnetorquers, and one reaction wheel. To establish a robust base for a series of future satellites, UE-3 additionally features an advanced modular and flexible architecture of the Pico satellite bus. In order to increase robustness, reduce mass, and add reliability in the overall system. One example is the redundant onboard data handling core module of UE-3, which is tolerant to SEUs, capable of repairing its own memory, and therefore able to recover the satellite and ensure safe operations. It's still up there working and handles SEUs and latch-ups and recovers. Only COTS parts were used, but fault detection, identification, and recovery by software and watchdog timers have ensured a level of reliability. Their data handling methodology is achieved through redundancy with mutual supervision and recovery, redundant serial flash, high precision real-time clock, and a quad redundant power cycling unit. UE-3 mission involved lots of amateur radio operators, and Dr. Schilling is very familiar with AMSAT-DL and highly complimentary of amateur effort and assistance. The attitude determination and control system has worked well enough to where they feel ready to try some formations. Formations are when the satellites communicate with each other and adjust their attitudes in space to maintain distance and all that sort of stuff without intervention from the ground. The range between satellites is up to 100 kilometers with a patch antenna on 10.475 gigahertz. The mixer, IF filter, modem, reference clock, synthesizer, PA, LNA, RF filter, antenna, etc. fit on a 40 by 20 millimeter PCB, according to the handout that I got. Attitude control systems on UE-3 include multiple magnetic field sensors, redundant gyroscopes, and interfaces with high-precision sun sensors. The attitude is estimated using an isotropic Kalman filter, while magnetic torquers are used for efficient spacecraft pointing. This is also available in combination with reaction wheels. The board interfaces directly via the Unisec CubeSat standard and is fully updatable in orbit. There's a scripting tool embedded in a sandbox environment on board so that you can test the algorithms and maneuvers at low risk and effort. It can do detumbling, pointing, and spin stabilization, even at 1U. This is so cool. Unisec, the standard that we've been talking about, has been extended past the electrical standard. There is also a satellite development board that can serve as an electrical ground support equipment after launch. Standardized testing came up as well in the discussion. Unisec standard satellites can be assembled in about an hour, which reduces the cleanroom time and makes it easy to upgrade or produce larger quantities. So all of this was really exciting to me because it means that the tasks of attitude control, power distribution, and communications are all successfully being done, and we can do it too. If we become familiar with this particular university project and others like it and build on it, then we can be way further ahead on amateur spacecraft design than we thought we were at the golf meeting at Symposium. There's an upcoming event for space people for autonomous control. If you're interested in formations and autonomous spacecraft, then bookmark this and check it out once they fill in the program. And that was just the first talk. The next one was about super awesome umbrella folding microwave reflector mesh antennas that pop out from CubeSats and give you real gain. In between that and attitude control, you can do Ka band in a CubeSat with 42 dBi. Now this pop-out antenna umbrella system doodad, it needs 1.5U to do it. So this is intended for like 6U CubeSats. But wait, there's more. He talked about a reflect array which is on the InSight mission that is delivering Marco CubeSats to Mars for communications relays. Now imagine all the benefits of a parabolic dish, but with the convenient packaging of a flat patch array. So check out more at the link in the notes. Next up was Dr. Mark Bachman, CTO of Integra Devices and a UC Irvine professor. He talked about how to make structures for millimeter wave and microwave applications using techniques more often found in the component packaging industry. This was pretty rad. They think it's the right technology for space, and they were pretty darn convincing. After that was William Deal from some company called Northrop. Their demonstration was a 666 gigahertz crosslink for inter-satellite communications. 9.5 gigabit per second data link. They showed off their demo of this data link, and that's really high up there, isn't it? Stephen Riesling from Colorado State University talked about remote sensing systems for Earth and atmospheric sciences using small satellites with a focus on TEMPEST, or Temporal Experiment for Storms and Tropical Systems. These are 5 identical 6U CubeSats that do repeat pass millimeter wave radiometry. They fill in a gap in the knowledge of cloud dynamics between formation and precipitation. It started up for real in 2015 and is supposed to launch in May 2018. What they do is scan 5 frequencies between 89 and 182 gigahertz. The last talk in the workshop was Dr. Ivo Vertat and ground station communications during shared launches. Amateur radio played a big part in this effort because the ground stations operated in the UHF amateur radio band, and hams helped sort things out and provided a lot of support. That evening, I got to set up a booth in the main hall as an amateur radio demonstration, along with 2 other volunteer demonstration stations from the San Bernardino Microwave Society. I'm a member of that club, and they are great. If you're near Corona, California, then you have one of the best microwave clubs in the country nearby. Brian Thorson, AF6NA, and Reen, W6SZ, were my fellow demonstrators. Jeffrey Paulin, WA6KBL, got us in the door with IEEE and supported us the whole way. We showed off microwave band amateur radio to engineers from Italy, Poland, Germany, Austria, Spain, Canada, India, and the U.S. all evening. There were lots of students. The food was great, the drinks were free, and I showed off the amateur satellite service, AMSAT, 3D printed 122 gigahertz Cassegrain antenna prototypes, dual band feeds for Phase 4 ground, 10 gigahertz elliptical taper 3D printed horns, and told plenty of tall tales. Huge success. There was lots of interest and plenty of awareness raised. There were 2 other satellite-related sessions, and I'll talk about those next week. I also went to a 3D printed antenna track and a 6-port structure track. I found out a lot of good information on 122 gigahertz RF from the vendor area and from my fellow delegates. Now, if you're into any of those things, let me know and we'll talk more. So wow, that was a lot of satellite stuff. We made a lot of contacts. We have solid offers of collaboration, and I'm going to do my very best to take full advantage of. Check out the UE3 papers in the Research Papers repository at Phase4 Space. We had a great time at the ham demo and promoted AMSAT and amateur radio and made lots of friends. Well worth doing, and I think we'll see plenty of results. Next year, Radio and Wireless Week will be in Orlando, Florida. So if you are in that area and can help demonstrate amateur radio and amateur satellite, the chair of the event wants you to come. There's a very large amount of enthusiasm and support for amateur radio at this and other IEEE MTTS events. So think about it, and let's start planning now.